Hello, today I'll make a general review for one-way analysis of variance. If you remember, it was a parametric method to compare more than two groups. We have two variables and one of the variable is qualitative and called as a factor, and the other one is quantitative, called as a dependent variable. Before I explained all process about hypothesis testing by one-way ANOVA, and here we'll repeat the application by a hypothetical example. Here is the example. We observe a total of 60 clients from 4 different psychological counseling centers A, B, C, D, and we gave them a scale about satisfaction with a 5-point Likert scale, and we measured them. There are scores for the center A, center B scores, center C scores, and center D score. Now I want you to compare 4 groups in terms of client satisfaction levels. First, we should write hypothesis for one-way ANOVA. For H0, it was the null hypothesis. We will say that for population, there is not a statistically significant difference between groups. Of course, sample means are different, but if we don't reject H0, we will say that for population, differences are not significant. H1 is the alternative hypothesis. We should write a sentence here, at least one group's mean differs. At the end, we will choose one of them. In the second step, we need a significance level. This is alpha, and generally we choose 5% significance level. In the third step, remember, we calculate a test statistic F, and it was MST divided by MSE. This was the variance between and the variance within. I made all calculations by using Excel, and I will show them. First, we need to calculate MST, or the variance between. What we need? We need general mean. This is the mean number 3.9. We don't care groups. We observed 60 people, and 3.9 is the mean of 60 numbers. This is the general mean. But there are the mean of each groups. For group A, the mean satisfaction is 4.3 out of 5. For center B, the mean satisfaction level is 3.6. For C, 3.3, and for D, this is 4.2. How we calculate the variance between? First, if you look at this formula, first sample size 15 multiplied by first group mean, and this is 4.3, minus general mean squared for the second group, for third group, and last group. This total will be found by subtracting the general mean from each group mean, and we divide it by number of groups minus 1. We have 4 groups, then we subtract 1. When we click enter, we calculate MST, or the variance between, as 1.8. Then we will calculate MSE. How we calculate it? It's longer than MST. We have all differences. If you look at this column, you see the differences between each number in group A and each group mean, 4.3. For example, this number 0.49 is found by 4.8 minus 4.3. this one 4.2 minus 4.3, like this. And squared differences we need. These numbers are squared differences for group A, and group total is 3.07. We use same calculation for group B. First we subtract the mean of B from each numbers under B column. For example, this one minus 0.33 is 3.3 minus 3.6. And squared differences for B column, and differences for C column, squared differences for C, and same calculations for D. First you will subtract group means from each numbers, and then you will take squared differences. Then by finding summations, we have group totals respectively 3.07, 13.58, 11.86 and 7.05, and we have group total. If you look at this cell, you see 0.64 almost, and this is 307 plus 1358 plus 1186 plus 705, and you will divide this total by 56. Why 56? Because this is n minus k, total n minus k. What is total n? 60 minus number of groups 4, and this is 56. Then we find MSE as 0.64 approximately. And then we have F statistic, and this is a ratio. You divide MST by MSE. At the end, you find F value, F statistic as 2.86. Now, we calculated this sample statistic by using our sample data. Now, I write my F statistic 286. This is calculated F. We should compare our F statistic to the table value. This is 5% F table. First degrees of freedom is 3. Why this is 3? Because we have 4 groups and we will subtract 1. It will be 3. And second degrees of freedom is 56. But in the table, we don't see 56 because numbers are very close to each other. If you have a large sample, then we will choose 60 instead of 56. And this is 276. This is the table value, 276. For decision, we should compare our F statistic to the table value, and we found table value as 2.76. I will draw F distribution. It's very hard to draw by using this pen and tool. Here H0 is rejected. Which value separate these two area? Of course the table value, and we found it 2.76, but our score is 256, and this is here. And it's not in rejection area. Then what we say for decision, 256 is less than the table value, then H0 is not rejected. means are not different, or there is not a statistically significant difference between four groups. Their satisfaction levels are equal in terms of population. We cannot say there is a significant difference for population. Thank you.